The National Electrical Code, or NEC, addresses the installation of motor control circuits and their relationship to power circuits. Specifically, the question concerns whether a 24-volt control circuit can be run in the same raceway as a 120-volt motor circuit when the motor controller incorporates a control transformer within the same motor and controller assembly. The answer is yes, the NEC permits this arrangement under certain conditions. To understand the rationale behind this allowance, it's crucial to delve into the relevant sections of the NEC that govern these types of installations. The primary concern when running different voltage systems in the same raceway is insulation integrity and the potential for voltage breakdown. Higher voltage circuits can induce current in lower voltage circuits if the insulation is compromised, leading to safety hazards and equipment malfunction. However, the NEC recognizes that control circuits operating at lower voltages, such as 24 volts, pose a significantly lower risk of insulation breakdown and inductive interference compared to high voltage power circuits. The presence of a control transformer within the motor and controller assembly is a key factor. The control transformer isolates the control circuit from the main power circuit, providing a degree of separation and limiting the potential for voltage transients or faults to propagate from the 120-volt motor circuit to the 24-volt control circuit. This isolation is typically achieved through the transformer's construction, which includes separate windings for the primary and secondary circuits, electrically isolated from each other. The NEC addresses the installation of control and power circuits in Chapter 3, specifically Article 300, which covers general wiring methods. Section 300.3 discusses conductors of different systems. This section generally prohibits conductors of different systems from occupying the same raceway, cable, or enclosure. However, there are exceptions to this rule, and one such exception applies to control and power circuits associated with the same equipment. Specifically, 300.3. C1 allows conductors of control and signaling circuits and Class 1 circuits to be installed in the same raceway, cable, or enclosure with power conductors when the control, signaling, or Class 1 circuits are functionally associated with the power utilization equipment. This exception is applicable in the scenario described, as the 24-volt control circuit is directly related to the operation of the 120-volt motor. The NEC also provides requirements for the insulation rating of conductors used in these installations. The insulation must be suitable for the highest voltage present in the raceway. In this case, the insulation on all conductors, including those in the 24-volt control circuit, must be rated for at least the voltage of the 120-volt motor circuit. This ensures that the insulation can withstand the potential voltage stresses within the raceway. Additionally, the NEC addresses the overcurrent protection requirements for control circuits. Article 725 covers Class 1, Class 2, and Class 3 remote control, signaling, and power-limited circuits. The 24-volt control circuit would typically be classified as a Class 2 circuit, which has specific requirements for overcurrent protection and wiring methods. Class 2 circuits are inherently power-limited, meaning the available voltage and current are restricted to reduce the risk of fire or electric shock. The NEC specifies the maximum voltage and current levels for Class 2 circuits, and these limits must be adhered to when designing and installing the control circuit. The overcurrent protection for the Class 2 control circuit is typically provided by a fuse or circuit breaker rated at a low amperage. This protection device is intended to protect the control transformer and the control circuit wiring from overloads or short circuits. The location of the overcurrent protection device is also specified in the NEC. It must be readily accessible and located in the primary side of the control transformer. Furthermore, the NEC requires that the control transformer be listed and labeled for its intended use. This listing ensures that the transformer meets certain safety standards and performance requirements. The label provides information such as the transformer's voltage and current ratings, as well as any specific installation instructions. In addition to the general wiring requirements, the NEC also addresses the grounding of motor control circuits. Article 430 covers motors, motor circuits, and controllers. This article requires that motor control circuits be grounded in accordance with Article 250, which provides the general grounding requirements for electrical systems. Grounding is essential for safety, as it provides a low impedance path for fault currents to flow back to the source, allowing overcurrent protection devices to operate and clear the fault. The grounding conductor for the motor control circuit must be sized in accordance with NEC Table 250.122, which specifies the minimum size of equipment grounding conductors based on the rating of the overcurrent protection device. The grounding conductor must be connected to the motor frame and the controller enclosure, ensuring that all metal parts are effectively grounded. The NEC also addresses the use of flexible metal conduit or liquid-type flexible metal conduit for motor control wiring. These types of conduit are often used to provide mechanical protection and flexibility for the wiring. However, the NEC specifies certain limitations on the use of flexible metal conduit and liquid-type flexible metal conduit for grounding purposes. In general, these types of conduit are not permitted to be used as the sole grounding means for motor circuits. A separate equipment grounding conductor must be installed inside the conduit to provide a reliable grounding path. The NEC also addresses the separation of control and power conductors within the motor controller enclosure. The NEC requires that control and power conductors be physically separated or shielded from each other to prevent inductive interference and ensure proper operation of the control circuit. This separation can be achieved by using barriers, partitions, or separate wiring channels within the enclosure. The NEC also provides guidelines for the labeling of motor control circuits. The NEC requires that motor control circuits be clearly labeled to identify a function and voltage. This labeling helps prevent accidental contact with live circuits and ensures that maintenance personnel can safely work on the equipment. The label should be permanently affixed to the controller enclosure and should be legible and durable. In summary, the NEC permits a 24-volt control circuit to be run in the same raceway as a 120-volt motor circuit if the motor controller includes a control transformer within the same assembly. This allowance is based on the isolation provided by the control transformer and the lower risk of insulation breakdown associated with the lower voltage control circuit. However, it is essential to adhere to all applicable NEC requirements, including those related to insulation rating, overcurrent protection, grounding, and conductor separation to ensure a safe and reliable installation. Furthermore, the NEC is not a substitute for sound engineering judgment. It is essential to carefully consider the specific application and the potential hazards involved when designing and installing motor control circuits. A qualified electrical engineer or electrician should be consulted to ensure that the installation complies with all applicable code and standards. In addition to the NEC requirements, there may be local codes or regulations that also apply to motor control circuit installations. It is essential to check with the local authority having jurisdiction to determine if there are any additional requirements that must be met. Finally, it is important to remember that electrical work can be dangerous. Only qualified personnel should perform electrical installations. Always de-energize circuits before working on them and follow all applicable safety procedures. By following these guidelines, you can ensure a safe and compliant motor control circuit installation. The National Electrical Code is updated every 3 years, so it's important to always refer to the latest edition of the NEC to ensure compliance. The information provided here is for general guidance only and should not be considered a substitute for professional advice. Always consult with a qualified electrical professional for specific applications. The NEC also addresses the use of surge protection devices for motor control circuits. Surge protection devices are designed to protect sensitive electronic equipment from voltage surges caused by lightning, switching transients, or other disturbances. The NEC recommends the use of surge protection devices for motor control circuits, especially in areas where lightning is prevalent. The surge protection device should be installed at the point of entry of the control circuit into the motor controller enclosure. The NEC also addresses the use of harmonic filters for motor control circuits. Harmonic filters are designed to reduce the amount of harmonic distortion in the electrical system. Harmonic distortion can be caused by nonlinear loads such as variable frequency drives, and can lead to overheating of equipment, nuisance tripping of circuit breakers, and other problems. The NEC recommends the use of harmonic filters for motor control circuits when harmonic distortion is a concern. The harmonic filter should be sized and installed in accordance with the manufacturer's instructions and the recommendations of a qualified electrical engineer. The NEC also addresses the use of power factor correction capacitors for motor control circuits. Power factor correction capacitors are designed to improve the power factor of the electrical system. Power factor is a measure of how efficiently electrical power is being used. A low power factor can lead to increased energy costs and reduced system capacity. The NEC recommends the use of power factor correction capacitors for motor control circuits when the power factor is low. The power factor correction capacitors should be sized and installed in accordance with the manufacturer's instructions and the recommendations of a qualified electrical engineer. The NEC also addresses the use of variable frequency drives, also known as VFD, for motor control. Variable frequency drives are electronic devices that control the speed of an AC motor by varying the frequency of the voltage supplied to the motor. Variable frequency drives can save energy and improve the performance of motor-driven equipment. The NEC contains specific requirements for the installation of variable frequency drives, including requirements for grounding, wiring, and overcurrent protection. The NEC also addresses the use of programmable logic controllers, also known as PLC, for motor control. Programmable logic controllers are electronic devices that are used to automate industrial processes. Programmable logic controllers can be used to control a wide variety of motor-driven equipment. The NEC contains specific requirements for the installation of programmable logic controllers, including requirements for grounding, wiring, and overcurrent protection. The NEC also addresses the use of human-machine interfaces, also known as HMI, for motor control. Human-machine interfaces are electronic devices that allow operators to monitor and control motor-driven equipment. Human-machine interfaces can display information such as motor speed, current, and voltage. Human-machine interfaces can also allow operators to start, stop, and adjust the speed of motors. The NEC does not contain specific requirements for the installation of human-machine interfaces, but general wiring and safety requirements apply. The NEC also addresses the use of remote monitoring and control systems for motor control. Remote monitoring and control systems allow operators to monitor and control motor-driven equipment from a remote location. Remote monitoring and control systems can be used to improve the efficiency and reliability of motor-driven equipment. The NEC does not contain specific requirements for the installation of remote monitoring and control systems, but general wiring and safety requirements apply. The NEC also addresses the use of energy management systems for motor control. Energy management systems are used to monitor and control the energy consumption of motor-driven equipment. Energy management systems can be used to reduce energy costs and improve the sustainability of industrial operations. The NEC does not contain specific requirements for the installation of energy management systems, but general wiring and safety requirements apply. The NEC also addresses the use of renewable energy sources for motor control. Renewable energy sources, such as solar and wind power, can be used to power motor-driven equipment. The NEC contains specific requirements for the installation of renewable energy systems, including requirements for grounding, wiring, and overcurrent protection. The NEC also addresses the use of battery backup systems for motor control. Battery backup systems can be used to provide power to motor-driven equipment during power outages. Battery backup systems can improve the reliability of critical motor-driven equipment. The NEC contains specific requirements for the installation of battery backup systems, including requirements for grounding, wiring, and overcurrent protection. In addition to the NEC requirements, there are also industry standards that apply to motor control circuit installations. These standards are developed by organizations such as the National Electrical Manufacturers Association, also known as NEMA, and the Institute of Electrical and Electronics Engineers, also known as IEE. These standards provide guidance on the design, installation, and testing of motor control circuits. It is important to be familiar with these standards when designing and installing motor control circuits. In addition to the NEC requirements and industry standards, there are also best practices that should be followed when designing and installing motor control circuits. These best practices are based on experience and are designed to improve the safety and reliability of motor control circuits. Some examples of best practices include using high-quality components, following the manufacturer's instructions, and performing thorough testing after installation. It is important to follow these best practices to ensure that motor control circuits are installed safely and reliably. In conclusion, the NEC permits a 24-volt control circuit to be run in the same raceway as a 120-volt motor circuit if the motor controller includes a control transformer within the same assembly. However, it is essential to adhere to all applicable NEC requirements, industry standards, and best practices to ensure a safe and reliable installation. Always consult with a qualified electrical professional for specific applications.